Non-decimal positional systems.
Okay, so we've been talking about base 10. Our number system is base 10. We have discussed some other bases briefly. We discussed the Mayans were base 20. Babylonians had some base 60. But let's think about how our system works. In base 10, we have 10 of these little guys, which I only have 5 here. But when we have 10 of them, they smush together and they form this stick. It actually has, if you can see, all the little tens lined up. When we get 10 of these guys, they smush together and they form one of these hundreds blocks. And you can see the grid where it shows all of the 100 on there. So here 10 is sort of the magic number, right? Well, we're going to look at some other bases. I'm just going to quickly show you some of base 3. So with base 3, and I'm going to use my Unifix cubes to make my own mats and strips and units for base 3. So if we look at the number 1 in base 3, we just have one little unit. And if we have the number 2, well, that's just 2 little units. But when we get to the number 3, if we have 3 units in base 3, 3 is the magic number. And when we have that base number, that's sort of our magic number that they're just going to magically magnetize, stick together, and now they're going to form a stick because we're in base 3. Okay. So the number 4 is going to be a stick and a unit. Okay, and I'm going to bring these over here and I'm going to actually start writing this out. Okay, so this is 1. This is the representation of 2. This is our number 3. This is our number 4. The number 5 is going to be a strip and 2 units. The number 6 is going to be a strip, and we put 3 units, so they're going to magically shoot together. So that's going to actually be 2 strips. Okay. Now the number 7, we're going to add on to that. There's 2 strips, and we're going to have a unit. The number 8 is going to be 2 strips and 2 units. And the number 9, well, that was going to be 3 of the strips. But when 3 comes about, when we have groupings of 3 in base 3, then they're going to stick together, and that's going to form a mat, like our hundreds, okay? So that's how that will look. Now, written with my black pen, and I'm going to bring that down a little bit. I have it all written in our base 10 notation. But now let's write it in base 3 notation. Well, the first ones are going to be pretty much the same. So 1 and 2 in base 3 notation. And by the way, we typically write the word 3 underneath so that we know. I'm going to be a little lazy from here on out. When we get to 3, we really need to look at our picture. It is not written with a numeral 3. It is written 1 stick, 0 units. This is going to look like what we would write 10. When we get to 4, we have 1 stick and 1 unit. By the way, there should be a 3 here on all of them. So keep that in mind. I'm not going to write them on all of them, but there should be. 5 is a stick, 2 units. 6 is 2 sticks, 0 units. 7, 2 sticks, 1 unit. 8, 2 sticks, 2 units. 9 is 1 mat, 0 sticks, 0 units. Notice that I never used in the numerals 3, 4, 5, etc. In your base, you will not use even the number that's that base. Think about how we write 10. We write 10 like that. In base 3, that's how you write 3. In base 4, that's how you write 4. In base 2, this is how we write a 2. In base 20, this is how you write a 20. Now, when you have a base that's higher than 10, what we are used to, because we only have 0, 1, 2, 3, up to 9. So when you have a base higher than our base 10, and you need to write the numeral 10, you see, if you're in base 12, if you write a 1, 0, that was going to mean 12 in base 12. So if you're counting in base, say 12, then you need to write like a T or something for 10, and an E for 11, and then here's 12. So if I'm counting in base 12, I have 0, 1, that should be a comma, but it looks weird. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's base 12. Okay, let's look at 200. Or 2, 1, 3, base 5. We have to get out of the habit of saying 200 there, because really that's not 200. So that's 2, 1, 3, base 5. So if I want to convert that to base 10, what I'm going to do is make a chart. So I have my 25s, my 5s, and my 1s. So instead of having my hundreds place, my tens place, my ones place, I have 2 in the 25s place, I have 1 in the 5s place, and 3 in the 1s place. So if you want to look at that, that's my mat. This is my strip. This is my unit, right? So I have 2 mats, 1 strip, 3 units. So in base 5, 5 is the magic number that everything's going to group up with. So once I get 5 of any one of these, it's going to magnetize. They're going to get together. So the strips have 5 little units within them, and the mats have 5 of the strips, which would be 25 units total. Okay, so this just becomes, if we kind of write this in expanded notation, then it's 2 of the 25s plus 1 of the 5s and 3 of the units. Let me color code that a little more. Since there's 2 1s here, I want to make it really clear where those come from. 25, 5, and 1. Okay? So then we get 50 plus 5 plus 3 So it's just 53 base 10. Okay, so now we're going to go the opposite way. We're going to take 81 base 10 and convert it to base 5. Now this is a little bit harder, actually. I would rather go from the other base to base 10. All right, so base 5s, again I have 25s, 5s, and 1s for, okay, just when I want it to auto shape, it doesn't. Okay, so in 81, by the way, the next one up would be 25 times 5, right? 5 cubed, but that's way too big for 81. So how many 25s can I get in 81? How about 3 of them? I think 3 25s would be great. Let me get that a little darker. 3 times 25 is 75. So let's use up 75 of those. So I'm going to have 6 left now. Okay, so I've handed out 3 of these mats that are worth 25 apiece. Think of a quarter. Now I have 6. Now I've got to hand out 5s, my strips. 1 strip of 5 should do it. Okay, just 1 will be fine. And I'm left with 1 now, and so that means I give out 1 of the 1s. So pictorially, this is going to be 1, 2, 3 mats, 1 strip, and 1 little unit. Oh, come on, unit, auto shape. There we go. So to write in base 1081 to base 5, that is going to look like, let me get my pen, 3, 1, 1, 5. Okay. Okay, so we're going to add 143 base 5 plus 234 base 5. So again, I want a place value chart. I think that's really helpful. So instead of hundreds, tens, and ones, I have 25s, 5s, and 1s. So I have for my first number 1 mat, 4 strips, 3 units. The second number has 2 mats, 3 strips, 4 units. Now, remember, when you add together, 5 is the magic number that's going to squish everybody together. So 3 plus 4, that gives me 7. That's what I'm going to think. But 7, we can't write that numeral 7. That little number written like that doesn't exist in base 5. We can only use 0, 1, 2, 3, 4, because when we get to 5 it looks like that, right? So we can't write a 7. So we have to think of this in terms of mats, strips, units, base 5 blocks. So that is actually 7 is 1 strip of 5 plus 2 more little units. So that is going to be
2 units and 1 strip. Okay. Now, I'll go through exchanging in a minute. 4 plus 3 here is going to give me the same thing. It's 7 in our mind, but when we write that in base 5, 7 is written as a 1, 2. And then 1 plus 2 is 3. So now we need to make some exchanges. So I need to exchange this stick to come over here. That's kind of sloppy. Let's make that look neater. We're exchanging a stick. Oh, that's better. So now I have a 2. Now we have 13 sticks and 3. Okay, I'm going to do another exchange. I'm going to exchange this. So that's going to give 1 more there. I really wish I had space. Okay, that's going to give me 1 more there. I'll make another line. So I'm going to have a 1 extra one here. So I still have my 2. I exchanged. Now I have only 3 here, and I have 4. So it's 4, 3, 2. Okay? Let me go back. Now let's work this the way that we would typically use our algorithm. And I think the really good thing about this is, I'm sure you're thinking, where am I ever going to use this? Who uses bases other than 10 anymore? The Mayans probably use base 10 now, what's left of them, and so forth. But actually we do use these other bases. Computers use base 2, the binary system, that's base 2. So there actually are practical uses for this. But the best thing for you is this gets you in the mindset of your students. Carrying this 1 and exchanging now requires a lot more thought for you. Have you ever had somebody teach you something and it was so easy for them that they couldn't remember the small steps and they really couldn't teach it to you anymore? Or have you tried to teach somebody something that was extremely easy? Sometimes it's hard to teach the easy things because those small steps we take for granted. We've done it so many times. This will make the easy things that were, or things that were easy for you, hard again, and you'll get back in that mindset of your students like, I've never done this before. So this really will make you think. All right, so we know the answer, but let's do this in the standard way. 3 plus 4 is 7 in base 5. 7 is a stick of 5 and 2 units left. 7. Okay. Now I add 4 plus 3 and 7 plus 1 more is 8. So luckily we've just done 7, so then 8 must be, if I'm thinking, 1, 3. Carry the 1. And 2, 3, 4, thankfully, works out nice. All right. Let's do a subtraction. This is 2, 3, 4 base 6 this time. Minus 1, 4, 3 base 6. Okay. I'm going to start with my place value chart. So here we're in base 6, so we don't have hundreds, we have 36s, and our 10s are now exchanged to 6s. And of course, ones luckily stay as they are. So I have 2, 3, and 4. And I have a 1, 4, 3. And I want to subtract. Okay. Now let's look. Do we need to make any exchanges? 4 minus 3, that's good. 3 minus 4, not so good. I need to make an exchange. So I need to get an extra one over here. So we're going to break up my 36 block. I have 2 of them. Going to break one of them up and give it to the 6 blocks. So now I'm going to get a 1, 3 here, and a 1 for the first one, and the 4 stays the same. So let's look at that again, okay? The larger number, the 2, 3, 4, was 2 mats, and they should be the same size, but they're just not. 3 of these and 4 little units. Okay. I needed to subtract a unit for, that should be a stick and not an oval. We'll just go over it. And 3. Okay. I don't have enough sticks. So I'm going to have to exchange this one and break it apart. Okay. So let me delete all this. Give us some more working room. Oh, let me erase what it'll erase. If it's not an auto shape, it'll erase. It's the auto shapes that require the lasso technique. Alright. And then maybe it's less to lasso. Oh, come on. Oh well. Alright. So I have 1, 3, 4, my 6's column now. That really is in the way though. Yay, okay. Yay, good. Sorry for the delay, but that was just in the way, but I thought the picture would help for sure. Okay, now we can subtract. Let's subtract the 1, 4, 3. So I had 4 of the little units, these little guys, take 3 away, left with 1. Okay. Resist the urge to call this 13. It is not. It is a stick of 6 with 3 units. So that's really like a 9. So think 9 here. 9 minus 4 is 5. So this is actually 5, 1, base 6. Alright, let's work this out the hard way. 4 minus 1 is easy enough. 4 minus 3, that's just 1. We like that. 3, I can't take 4 away, so I have to borrow. So I'm going to get another stick in the 3 that I had. 1 stick of 6 plus 3 units is actually the number 9. 9 minus 4 is 5. Okay. Let's do a multiplying problem. 3, 2, 4 times 1, 5. And these are also in base 6. Okay. Now I'm just going to do this one with the normal algorithm. Okay. So 4 times 5 is equal to 20. That's base 10 notation. Base 6 would write 20 as 1, that's 6, 12, yikes, 12, 18, 19, 20. That's 3 sticks and 2 units. 3 sticks, 2 units. Okay. 2 times 5 is 10 plus 3 is 13. 13 in base 6 is 2 sticks, that makes 12, and 1 unit. So that's 1 unit, 2 sticks. 3 times 5 is 15 plus 2 is 17. 17 in base 6 is 1. 2 sticks, that's 12, and 1, 2, 3, 4, 5 units. Okay. Now, let's multiply the 1 times the 4 is 4. 2 times 1 is 2, and 3 times, what is my 2 not want to write? And 3 times 1 is 3. Now we add, we get 2, 4 plus 1 is 5. We're still doing good, not over 6 yet. Uh-oh. 5 plus 2 is 7. 7 is greater than 6, so we've got to convert it to base 6. That's 1 stick of 6 and 1 unit. So we write that as 11. Or like we would write 11. So that's 1. And then add a 1 over there. 5, 6. 6 in base 6 is written the same way we would write a 10. That's 1 stick and 0 units. Base 6.